Hi, and welcome to Free Response 2013, number 6 for BC Calculus. This is a question about the Taylor series. If you haven't already, you should probably print out the question to follow along, as we'll focus more on the solution than the question. You can download the question from this link. It'll have the PDF with the scoring guidelines, as we'll go into a little more depth than those scoring guidelines. I encourage you also to try it yourself first, so that you can kind of go over the nuances with us. Now note, this is question 6, so no calculator is allowed for this question. In part A, we're going to be asked to show that f prime of 0 equals 2. So a few things before we get started. We're told that the function f has derivatives of all orders. We need to know that so that we can create the Taylor polynomial. And we're told to let Pn of x be the nth degree Taylor polynomial for f about x equals 0. So that tells us that the center is 0. We want to be real careful with notation on this question. In the scoring guidelines, the graders specifically point out that students mixed up f and p of x, and they really are looking that you know the difference between the function and the Taylor polynomial approximating the function. So this was not a typical Taylor question. Usually you're given a function, asked to find the Taylor series, and then you do a few other things with it. Instead, they were really testing if you understand how the equation works and can kind of manipulate different parts. Once you understand how to do the problem, it's fairly straightforward, but seeing this on a test for the first time probably threw off some of the students. So in part A, they tell you f of 0, and they tell you p1 of a half. And you're asked to show that f prime of 0 is 2. So what you want to do is write out the polynomial of degree 1. So in the first step, we do that here. P1 of x is f of c plus f prime of c times x minus c over 1 factorial. That's just the general equation. Now we're told that the center is 0, so all those c's can become 0, and we can fill in the other information we know, namely that f of 0 is negative 4. So in the second line, we know f of c, f of 0, is negative 4. We still have f prime of 0 there because we're trying to show that it equals 2. We can't assume that it equals 2 here. And then because c is 0, x is all that's left, because really we have x minus 0 to the 1 power over 1 factorial. All that's just x. All right, the next part is plugging in 1/2. So we're told in the question that p1 of 1/2 is negative 3. So that means when x equals 1/2, we can plug it in. So this x in my second equation, I'm going to plug in 1/2 for. And I know that that whole equation equals negative 3. So once I have that set up, I really just add 4 to both sides to get 1 on the right side, and multiply both sides by 2 to finalize it and show that f prime of 0 equals 2. The scoring for this part gave 2 points, 1 for using p1 of x and 1 point for verifying f prime of 0 is 2. Again, the graders were really interested in students using correct notation here and knowing how to use the Taylor polynomial. So writing the Taylor polynomial for p1 of x was important, as well as doing what the question asked, verifying f prime of 0 is 2. Mistakes, again, that I suspect were made here were probably plugging in 2 for f prime of 0. Okay, that would be assuming that it equals 2 rather than verifying that it equals 2. The other mistake would probably just not know where to get started on this. Because it doesn't look like a typical Taylor polynomial question, I'm sure some students just had to think a little while and maybe ran out of time on this problem. Keep in mind, every number 6 in the last few years has been a Taylor polynomial question. So I would say once you hit number 6, write the Taylor polynomial notes out for yourself quickly, and then see where you can go from there. Even if you're hit with something like this that's in an unusual format, if it's a Taylor polynomial question, you're going to use the Taylor polynomial somewhere. Okay, moving on to part B. In part B, we kind of have a similar question, only we're asked about to find P3 of x. So actually, I think if people got part A, I would think most students also then got part B, since it was very similar. You're given f double prime and f triple prime of 0, so you have those coefficients. So what I did in the first line is just write out the general Taylor polynomial here. So we have degrees 0, 1, 2, and 3. Please remember that when we're talking about P3 of x, it's going to have 4 terms sometimes because of that first x to the 0 term. From there, we plug in the things we know. From part A, we know that f of 0 is negative 4. From A, we also know that f prime of 0 is 2. Then in B, we're given f double prime of 0 is negative 2/3, and f triple prime of 0 is positive 1/3. And finally, I just simplify. So I get negative 4 plus 2x minus 2x squared over 6. I could also have x squared over 3 there, plus x cubed over 18. So this question gave 3 points, although again, I think if you got part A, you would probably get part B just because of the really similar aspect to it. So you got 1 point for the first 2 terms, 1 point for the third term, and 1 point for the fourth term. Again, they're looking that you used proper notation here, so that you called it P3 of x rather than T of x or f of x or anything like that. On the last part, you had a little bit more work to do. So we're told that h prime of x is f of 2x and that h of 0 is 7. The AP exam writers like to do this. They like to define a new function, h, in terms of something that you already know. The exam scoring guidelines gave 2 ways to do this, but I'm just going to go through what I think would be the most common for you. You'll have noticed on a lot of the Taylor series questions or review questions, I've put in this idea that you use one function to find a new function. So that's how we can solve this. We have P3 of x, we can find P3 of 2x. So I'm plugging in 2x for all the x's I see in my function here. Then I simplify on the third line. So I have negative 4 plus 4x minus 4x squared over 3 plus 8x cubed over 18. And yes, we could simplify that a little further. And I've got now P3 of 2x. Now unfortunately, it was h prime that equaled f of 2x, not h. So if I want to get to h, I'm going to have to integrate here. So I integrate term by term this P3 of 2x polynomial. Again, that's a common skill we've seen used, and you'll often have to find the antiderivative or derivative of a Taylor polynomial. So from there, we integrate term by term. We get our function here, but we have a plus c. To fill in that plus c, we're just going to use that information they gave us. H of 0 is 7, so that's my initial term is going to be 7. So finally, I have my polynomial here. 7 minus 4x plus 2x squared minus 4x cubed over 9. Now you might have thought I dropped a term here, but actually they asked for just the third degree polynomial. So I'm only going up to the x cubed over 9. Finally, on the scoring, you get 4 points for this question. They really wanted to see that you use the h prime equals f of 2x, and then you got a point for the constant, that's the term h of 0 equals 7, and 1 point for the remaining terms. There is an alternate solution online if you'd like to look at that as well.